Welcome back to Math Concepts. In this video, we are going to discuss the process of finding the probability of an event. So remember, the probability of an event is a number that tells us how likely the event is. The closer that number is to 1, the more likely our event is. The closer to 0, the less likely the event is. So the probability of an event is always a number somewhere between 0 and 1. And the way we compute this number is we have to count the number of ways our event can happen. We put that in the numerator of our fraction. And we count the number of things that could possibly happen, and we put that in the denominator. So we make a fraction by doing that. So we're going to use the counting principles at least some of the time to answer questions about probability. So let's go to the document camera and look at some examples of computing the probability of events. Okay, so the key takeaway from this video is you should be able to compute the probability of an event. And remember, to find the probability, we make a fraction. For the numerator, we have to count up the number of successful outcomes. For the denominator, we have to count up all elements in the sample space. For short, I usually just say probability is success over sample space. So here we're going to look at a couple of examples. These first two are related here. Okay, so the one I really want to get to is we toss a coin twice. What is the probability of getting heads both times? Okay, but before I do that, I'm going to need to answer this question. A coin is tossed twice. What is the sample space for this experiment? So this question actually asked me to list out the sample space. So my answer is going to be a set, which I'll put in braces right there. But before I do that, I'm going to use the counting principles to determine how many elements should be in my set. We're tossing a coin twice, so it's a two-stage experiment. How many ways can the first toss come up? Well, that's easy. You got two options. Your toss could come up heads or tails. Same thing for the second toss. Okay, so the sample space needs to contain 4 elements. Each of the elements is going to have 2 parts. HH, I'm sure you understand what that means. It means heads on the first toss, heads on the second toss. HT means heads then tails. TH, tails then heads. And then finally, tails both times. Looks like I gave myself a little more space than I needed. So there's our sample space with 4 elements. Okay. Now that we have the sample space, we can answer this question. What is the probability of getting heads both times? Well, looking up here, there is exactly one event that meets our criteria, one thing in the sample space. So the probability of getting heads is 1 in 4. Okay. And of course, we could write that as a decimal. And of course, that's also a percentage, 25%. Okay. Typically, you'll be putting your answer as a fraction. I really like to see the fraction version of probability. So let's look at another example. 2 fair dice are tossed, and we're just going to have these be the standard 6-sided dice. Okay, so what is the probability that the sum is? And this is the first example we'll look at. So we're going to look at two options here. So the question is, what is the probability that the sum is 7? Okay, so let me show you a nice little picture that sums up all the options when you toss 2 dice. So for convenience, let's just pretend that one of the dice is green and the other one is red. Okay, so this right here, that's a single outcome. Both of the die show up to be 1. Now we're talking about the sum being 7. Okay, and in this picture they've actually got it circled for us. Okay, so, oh, do they? No, that looks like that's an 8. Okay, we want 7s. Okay, so I'm going to ignore those circles. Okay, so this is one way to get 7. Green die is 6, and the red die is 1. 6 and 1. 5 and 2 is another way. 4 and 3. 3 and 4. 2 and 5. 1 and 6. So there are 1, 2, 3, 4, 5, 6 ways to get a sum of 7. And if we count these up, there's 36 possible outcomes to our experiment. So let's go back and answer our question. Okay, so what is the probability that the sum of the two dice is 7? Well, we saw there were 6 ways to get a 7 from our chart. And from the chart, we can also get that there are 36 possible outcomes. I could also do it this way. We're tossing 2 dice, so it's a 2-stage experiment. First die can come up any of 6 ways, so can the second. Sample space has 36 possible outcomes. So the probability of getting a 7 is 6 out of 36, and this fraction reduces to 1/6. Here's another problem. Find the probability that the sum of the pips on the 2 die is at least 10. Now, if you roll the video back a little bit, you can see all the possible outcomes. The smallest sum you can get when you're rolling 2 dice is 2, and the biggest is 12. Okay, so at least 10 means we're talking about a sum of 10, 11, or 12. Okay, now the denominator is still going to be 36. There's 36 possible outcomes when you roll 2 dice. How many ways to get a sum of 10? Well, you could get 6 and 4, 5 and 5, 4 and 6. There's 3 ways to get a 10. There's 2 ways to get an 11, and there's 1 way to get a 12. So this actually works out to be 6 over 36 also, but for a different reason, and it reduces, again, to 1/6.